Hello everyone, I'm Gotem. Today we will talk about microfilaments. We talk about only the things which are high yield and which you must know about microfilaments. Okay, let's begin. Microfilaments are part of cytoplasmic cytoskeleton. Cytoplasmic cytoskeleton consists of three components. First are microfilaments. Microfilaments. Second are microtubules. Let's type it. Microtubules, second. And third one is intermediate filaments. Intermediate filaments. So these three components are part of cytoplasmic cytoskeleton. What is their function? Their function is any movement in cytoplasm in the cell, contraction reactions, and movement of organelles, and cytokinesis. This is the function of these cytoplasmic structures. Where the location of these microfilaments, microtubules, and intermediate filaments. Let's talk about location. If it's outer layer of cell, bottom layer of cell, here is cytoplasm, and here at the bottom and at the top, let's do it with different color. Here is microfilaments. Here is microfilaments at the bottom and at the end, at the top of the cell are microfilaments. These are microfilaments. Where is intermediate filaments? Let's do this in red. Intermediate filaments are here inside cell between microfilaments. It's intermediate filaments. Let's color it red. And where is microtubules? Microtubules is also inside cytoplasm, but here. Let's color it in green. Here is microtubules. Right. microtubules. So you can see where is a location of microfilaments, intermediate filaments, and microtubules. Each cell again, each cell, outer layer of cell, its bottom layer, and near bottom layer and outer layer there are microfilaments. Let's talk about microfilament structure and function. Firstly, we can say about microfilament function is contraction of muscle, is actomyosin complex, and on this contraction takes part microfilaments or F filaments or actin filaments. Microfilaments, actin filaments, and F filaments are synonyms. These three are synonyms. Let's color it in blue. Here it is. These three names are synonyms each other. Synonyms. Okay. What is the structure of these microfilaments? We can say that microfilaments are very tiny structures. Their diameter is 5 to 7 nanometers. Very tiny. Smallest structure of these three: microfilament, microtubule, intermediate filaments. Smallest structure are microfilaments. Okay, now talk about microfilament structure and microfilaments subunits. Microfilament subunit are globular actin or G actin, and it's G actin. G actin, G actin. This globular structure are together to G actin. Sorry. It's G actin 2. And this composed of subunit of microfilaments, and microfilaments structure is like that. Here is one G actin, here is another, and they are connected with each other. It has structure like chain, double-stranded chain, like that. These two circles are G-actin, G, globular actin, G, and it's polarized. Here is plus, here is minus. Okay. Each structure of microfilaments, and this G-actin is called monomer, and these are polymers. So another topic about actin filaments. Assembly and disassembly of actin filaments. It's very important because if we are saying that this structure F-actin F-actin is main factor of cellular movement, contraction, and movement of organelles. How can it manage this movement? This mechanism is its property that it's very dynamic structure. This structure F-actin, let's paint here a little, more little, without this globular structure here, and we can imagine that it's a little variant of this picture. Okay, and it's larger structure, and here is plus side, here is minus, here is plus, here is minus. At the end there are many free globulins, free monomers, many monomers in this space, and there are also protein which called profilin, which promotes assembly F-actin chain from these monomers. From these monomers assembly this chain. This is protein profilin. Protein profilin assembly this side. If we imagine that this profilin constantly add these monomers here at this situation, this chain must be longer and longer and longer and longer constantly. But it is not true, because here is at the opposite side, here is protein coupling. Let's paint it in red. Coupling, it's also protein. Which is responsible for disassembly this site. Profilin assemblies at this site, coupling disassembly. So if this monomer is here, after several hours, this monomer will be here, then will be here, and then we'll disassemble it. But a new structure will be formed. A new monomer will be at here. So this structure, this length of the structure will be same. Length of the structure will be same. But it's dynamic structure, and it is called treadmill. It's like a treadmill. It moves all time, but the length of the structure will be same. This filament structure will be same, but these polymers in the structure always move from here to here, from plus to minus, and this promotes movement of organelles in the cytoplasm. Also, very important function of affecting or microfilaments are they take place in cytokinesis during mitosis and meiosis. They take place during mitosis and meiosis. Cytokinesis. Their function is cytokinesis too. Okay, and another important issue, there is APR2/3 protein which promote F-actin networks, creating F-actin networks. If a filament is here and this protein is here, this protein adds another filament here and here and here, and etc., and it will create filament networks here, and etc. And it creates cytoskeleton too. Okay, it was let's summarize our topic. Cytoskeleton structure has three components: microfilaments, microtubules, and intermediate filaments. Microfilaments are smallest structure. So they have smallest diameter and radius. Location of these filaments looks like this. If this outer layer of cell, this is another outer layer, opposite layer. These red are intermediate filaments, green are microtubules, and these blue are microfilaments. So microfilaments are located at the beneath of the cell wall. Microfilaments, actin filaments, and F filaments are synonyms. Their diameter is 5 to 7 nanometers. Subunit of this microfilaments is globular actin or G-actin. G-actin are connected with which is other. These monomers are connected, and microfilaments are double stranded chain, and it has a spiral form too. If we try to paint it, it will look like that. Imagine that this structure is smaller, very small, and it look like spiral, double stranded chain and spiral form. Okay, F-actin. Microfilaments are polarized. This side is plus, this side is minus. Profilin is protein which promotes assembly from monomers. These points are monomers. Assembly at this side, and cofilin is protein which promotes disassembly at the minus side with disassembly. So this process is dynamic, always assembly and disassembly of microfilaments, and this promotes movement of organelles. Microfilaments also takes place in cytokinesis. APR 2/3 protein promotes formation of network of microfilament network. So thank you for listening, thank you for interesting. Please subscribe our channel and like videos. Thank you very much. Bye.